For station number 4, the most challenging aspect of this question, or these questions, is probably going to be the time, especially for the challenge question at the end. In the first one, we have Speedy the snail, who's not starting at the 0 mark on a ruler, he's starting at 10, and he's also not starting at a time of 0, he's starting at a time on the clock of 2 o'clock and ends at 2:10. In order to do this, we need to use our speed equation, which is distance divided by time. And the distance part is if he starts at 10 and ends at 65, we want to find the difference between those two spots on the ruler. So we have to subtract them, and that comes out to 55 centimeters. For the time part, since he starts at 2 o'clock and ends at 2:10, the difference in that time is how much it took. So that's 10 minutes. So we find out that he goes 5.5 centimeters every minute. Make sure you have your units correct. In the second one, we want to know what his acceleration is, so we're going to use our acceleration equation. And we know that he can go from 0 to 6, that's the change in velocity of 6, and it takes a half a minute, so 0.5 minutes. And then we get a kind of a funky unit for the acceleration, but it's 12 centimeters per minute. That's his velocity, centimeters every minute. And he can change that velocity every minute. So that's where we get centimeters per minute per minute. For the last one's pretty challenging. In order to do this, we have a strange time on the clock, and we want to know what is the change in time in order to add it to this on the clock to figure out what it'll say once this person stops accelerating and reaches her top speed. In order to do this, we have to use our acceleration equation, and since we know her acceleration is 0.15, that goes here in place of a. Her velocity went from 2.3 up to 2.9, so if we subtract those two numbers, we're going to get a change by doing this math right here of 0.6, and then we just put it over our delta t, since we don't know how much time it's going to take her. In order to get delta t by itself, we first have to multiply this side and this side by delta t to get it off the bottom. When we do that, I've just rewritten this expression right here, since 2.9 minus 2.3 is 0.6, and the t came off the bottom, and we multiplied it by the 0.15. Now we've just rewritten it here. Now we just divide both sides by 0.15, and we get an answer of 4. So it took her 4 seconds. Now we go back to the question where it says what her time was beginning of her acceleration. We just have to add these 4 seconds to that time to figure out what the clock says when she's done.